Right. Some restaurant has been removed. I don't know it is showing Sonal as a removed. Okay. So primarily now our focus is basically into the second portion or second phase of uh, index block, which is text transformation. Study in the study lecture, previous lecture, we have opened up about the different different possible computing blocks we could have within this text transformation module. So here the first part, which is called parsing, it will be applicable for uh, all these three concurrent processing. So within this text transformation we have three concurrent processings. One is for processing the actual text part, right? Because whenever we will be gathering the data from a web source or maybe from any kind of source, we could have these three broad types of content. First half content type in the nature of text or textual data, right? The textual data means the data which is having simple text. It is not having any hyperlink. It is not having any HTML content. It is not having any multimedia files, right? Or maybe it is not having any metadata kind of things. So typically, to process very first type of content, web content, which we have gathered, we have this first arrangement, right? First kind of arrangement means it is having all these uh, textual type of content, right? You can see here in the very first processing line or maybe assembly line, you can say we are having a stopping and stemming mechanism, right? So this mechanism or this layer is to process only text part, only pure text part. It is not having any content which is beyond, which is of different structure, right? So it is basically most of the content which we gather during text acquisition of this nature only. So for pre-processing, particularly in the web content, right? So if you are processing the content from email, it could have not having this. It could be having some multimedia files also and other things also. But particularly if you are going to process the content which is collected from web, it could be having larger portion of this nature, text nature, right? So text nature means you have gathered the profile details of a certain individual. It could be a content extracted from the web page, which is not having any web link or any hypertext kind of thing, right? So basically, to process this larger portion of the content, we have these two components in the first track of first layer of processing, first type of processing. Then we could be having some contents which is of nature links and all these things. So for this, we have this middle layer or the second type of processing. And for remaining types like metadata kind of content, we have this information extractor and classifier. So you can take a note of this point that whenever we are gathering the data from the internet or from the web, there is a possibility of multimedia contents also, like images, videos, food, and other non-structured data, right? Particularly of multimedia nature. So whenever we will be encountering these kind of data, we need to perform some kind of metadata processing, right? So like if you are collecting multimedia or maybe images or audio files or any kind of multimedia content, we used to collect tags and links and lot of contents which is of this metadata nature. So if you are collecting the data, images data, these tags to the image are considered as a metadata. You cannot say that the tags are data. They are not data. They are data, tag terms. So suppose there is an image and there are a few tags attached to it. You need to deal these tags as a metadata because they are describing this data image data or data image. You can both way you can use, right? So similarly, it is very important to have a separate arrangement for collecting or processing these metadata kind of details, metadata kind of contents from the collected whole content, whole data from the web source, right? So that's why, so most of the things which are like of metadata nature are to be processed through this third layer of processing, third way of processing. So any kind of data which we gather from the net, we need to process or we need to send by one of these three layers of processing, right? And it is naturally the responsibility of parser, because parser is the block or the processing label which can easily identify the nature of the content, which is basically which parser is receiving from the text equation block. Naturally, so if you can recall, in the text equation block, we have placed a content called conversion. So conversion is the process in the text acquisition which will naturally remove the most of the structured part. So suppose if you have extracted the HTML code from a website, this conversion process will remove this structure of HTML which is attached. It will extract all the textual aspect of the web page from a HTML page and arrange it to a maybe text file or maybe Word, something like that. It will remove the hard structure part from a content. So it is basically, it is like, you can take this example or reference. It will be removing this templating part. It will remove the template structure. It will remove the hard template from the data. It will take out all the content, right? Like we used to do in the non-practice. We used to go to the website and simply select the content and copy the content into a Word file, something like that. So basically, conversion is to remove this hard template structure, right? It will take out all the content and convert it into the words form or maybe collection of words, and then it will be simply sending it to the parsing component. So basically in this entire processing from text equation to text transformation, one of the important aspects is to maintaining the identity or maintaining the uniqueness or maybe identification mark for each document, right? You will be collecting a lot of documents from the web, and during this acquisition and transformation, we will be processing each document. So across this entire process, you need to maintain the identity of each page. You should always have some identifier to identify a certain document. Naturally, you will be performing a lot of text processing, but you do not need to, I mean, it is very dangerous or it is a bad situation to lose the identity of some document. You should always have an identifier, right? So it is an internal mechanism to have an identifier for each document, but it is an important aspect that, okay, we have gathered these number of words from this one unique identifying documents. You need to have this identifier which will establish that all these words, all these texts are belonging to this one single document ID, something like that, right? So it is a typical situation that you have to maintain your own way of maintaining the identifier, and eventually when you will be generating these index terms. So after this text transformation phase, you will be having a set of or maybe bag of index terms. So to indicate the set of words, set of index terms, again you need to maintain that identifier, right? Document ID or any kind of identifier you can have. So it depends upon the system which you are building, that what is the mechanism you have adapted to maintain the document ID. So it is a typical process. So like yesterday, we have slightly open about how each individual block or how each block will be treating these tokens from the parser, and how each block will be processing it to achieve something. But eventually, we have to transform the received data, received collection of words or words from text acquisition, and convert it into the form of index terms, right? So I hope you have some perception about this thing. Now, can you tell me, if you have words as an input, can you tell me, to achieve this input in the form of word or maybe collection of word, what kind of processing we need to apply, right? So if you have these words or set of words, a collection of words as an input, and we need to generate or we need to produce after processing in form of terms or in form of searchable terms or index terms, because I have written this term called searchable terms. Searchable terms means this is how we are asking, this is how we are applying the keywords into the search system. So eventually you need to achieve from the set of or collection of words or collection of documents from the text acquisition, we will be performing something inside this text transformation block, and outcome will be index terms. Now you can correlate these index terms are the terms which we as a user are applying into the search system or any search engine, right? So whatever keywords we are imposing to the search system, these keywords are most of the times are similar to the index terms. So that's the objective also. So the objective of text transformation block should be achieving or should be producing the terms, index terms or potential terms which could be similar to the possible user terms, possible user query terms, possible user keywords, right? And that's the success of text transformation block. If text transformation or text processing or text pre-processing, you can say, could achieve that level of text transformation, then we can say this block is performing successfully, because if you can get all those kind of terms which will be in the future, which will be closer to the user's query, closer to the user terms, then our search system will be a successful. It will be considered as a successful system, right? So to achieve these level of terms, these level of searchable terms or index terms, you can say what kind of pre-processing, what kind of filtration you can say, or maybe transformation or denoising, you can opt for any term, and these are the different terms which are used in the literature also. So what could be the possible filtering or pre-processing we should be applying? So you can also respond to this question. So like you have given a lot of content, lot of data content extracted from the internet, and it is given to your system. It is given to you, right? So what kind of contents you should be removing? And naturally, outcome and objective should be having these set of searchable terms and searchable keywords, right? So you can list out all these possible types of content, right? So like the very first thing you should be removing is the space, or maybe between these two key terms you could have a lot of spaces. So you should be having, you should be denoising the content by simply removing these spaces. What could be the others? You can also respond to the chat box, right? So tokenization of data is in the document. Okay, so tokenization is okay. So comma, full stop, yeah. So we can remove all these separator, I can see, right? So all these things you can note down here. Spaces, comma, full stop, all these things. Okay, so after this first type, so I'm assuming this space within text is comma, full stop, any kind of mark separator could be placed on the first category. Second category could have which nature? Just let me know. So marking the data, okay, converting to the lowercase, yeah. So it is basically uppercase to lowercase. Right. So this is one type of possible conversion we can have broadly. Then I can read the comments. Okay, comments. Jatin, I'm not sure what about comments. Dipanshu, are you working somewhere? Okay, so removing stop words. Okay, stop words is a broad thing. We've been talking about it. So stop words, punctuation like and at the rate and all these hashtag words. Okay. Mukul is saying making the data more structured, removing the repeated words. Yes. Repeated words are Akanksha, repeated words are called stop words only. Marking the data, converting to lowercase, it's already read. Tokenization, I have read. Punctuation, bringing the data into subparts. Okay, it is the basically Kumalji, bringing the data into subpart. It is basically covered by this whole 3 steps. We will be achieving these terms in a very small size of tokens, small size of words, or in the terms of token index terms actually. Okay, stop words are like, okay, stop words are like A and the, naturally it is all these things, stemming normalization, text normalization, comments of self-consumption, the thing says removing the redundant elements. Okay, so I wanted here to be posted more direct answers that from the given text, these are all things I will be removing to achieve the absolute term. Like you can relate it with your search behavior. So whenever we are going to the search system for some for searching about some topic, searching about some given assignment, what are the things we used to avoid for typing, right? So we used to go to search system and type a simple keyword. We do not used to type any sentence, right? So it could be a part of speech, something like that. We used to avoid typing part of speech-based sentences or inputs. So in the search system also, you used to avoid these kind of structures, right? So we used to avoid propositions. So all kind of things which, as a user of search system, as a user of search engine, we should be we used to avoid typing while applying a search, while performing a search. We should be removing all those possible things during this text transformation, right? So you could be having 5 or 6 different types, broad types of things, right? So you can easily correlate with. So because this text transformation block is basically providing or preparing the content with respect to users behavior, with respect to user expectation, right? And that's why it is very critical phase. And you can believe me, these all these components like stopping, stemming, link analysis, extraction, information extraction on classifier, these are closely related to the human behavior, right? So what a human, what as a user we used to avoid to do while going for search, while going for perform some kind of retrieval or extraction, right? So each and every component is performing some user's behavior, right, to make a component, to make a content in a user searchable manner, right? So the very first thing is naturally is parsing, which we are applying. So if we open up about the very first content or module, which is called parsing. So parsing is basically, you can say, whenever we are parsing the content or maybe anything which is given to the text transformation block, parser is the very first entity which will be receiving all the content from text acquisition, and it will perform 2 broad activities, 2 broad responsibility. First responsibility is to recognize the content, right? And naturally, if you want to recognize the content, so recognizing the content means you are trying to identify the possible type of the content. So whether it is a simple text, whether it is a hyperlink or maybe web link or URL, whether it is a metadata or whether it is a non-text content. It is a multimedia file, it is an image file or any kind of things, right? So to recognize the nature of the content, you need to analyze the structure of the content, the structure of the data, right? So for that, it will be so this parser content, parser processing component is having a lexical analyzer as a main, as a key processing, key computing block. So you might have a naturally internal idea about how lexical analyzer is working to perform some task, to perform lexical analysis. Lexical analyzer component is basically based on or adapting some kind of label also, symbol table, or maybe you can have any kind of table, because based on that only you can recognize, right? So this entire system or entire discussion on lexical analysis and how it is preparing the tables, how it is using the table to identify the content structure, to identify the tokens, possible tokens, right, or to produce the token. So it will take out the input, right? So input will be naturally the web content which we have collected, and we will be sending these input content to the parser block where we have placed this lexical analyzer, and this lexical analyzer component will be, it will be verifying or it will be matching each and every incoming character, incoming data content, and based on the symbol table, based on the table which he has with us, it will identify the validity of it, and it will be performing some kind of syntax check into it after basically recognizing the content. And so basically within this lexical analyzer, we will have the inputs from the symbol table. So symbol table can be customized also, because if you are adapted the, for lexical analysis, you have, if you have adapted English literature or English terms, English dictionary, it has a specific dictionary, it is having a specific symbol table. But if you have adapted a lexical analyzer for Hindi, you will be having different symbol table and different dictionary, right? So for each, so it is again very specific to the language or for the input language. So always it is, this lexical analyzer will have its own symbol table, its own dictionary to identify the validity of the input character. So based on these two inputs, symbol table and dictionary, it will identify the possible token. So all these symbols, all these contents available in the symbol table, in the dictionary, will be converted or will be used to define or derive a token, right? So all these things which are available in these two inputs, broad inputs, symbol table and the dictionary, will be mapped as a token. Others will be removed. That's for sure, right? After getting the tokens, it will be identifying the syntax of the token, right? Syntax. So this syntax analyzer is the analyzer which will be analyzing the contents organization, and based on that, it will say, okay, this is a text content, this is a proper URL, this is a proper metadata, this is a different type of data, right? So again, to syntax analyzer is basically achieving or preparing these tokens into some data structure. It could be a type of tree, or it could be a type of anything, graph also, right? So basically syntax analyzer will arrange all the received token into some structure to define its type, to define or recognize its type. And once it is basically have this certainty that the received token or this received content after lexical analysis has been this nature, it can easily revert back to the components like stopping and like link analysis, or maybe like information extraction, right? Here this whole process is shown as entirely loop based, right? Because this once this syntax analyzer has derived some token, it can send these tokens for lexical analysis for again check, or maybe for again verification. But in this text transformation systems, we are performing this whole process in one go. Like after getting in characters or after getting inputs, it will be sent to lexical analysis, and lexical analyzer will simply identify the validity of tokens, that how a given input could be converted into the tokens, and these tokens will be basically sent to a syntax analyzer, where syntax analyzer will arrange all these tokens into some structure to identify its basically to analyze the nature or to analyze the content type. And after this, the syntax analyzer will be sending the derived nature content to the stopping and to the further stemming part, right? So if you take this simple example, we have placed a simple sentence. So carefully, if you see this input text, it says Microsoft's 2020 biannual report showed profit rose by 21% and dot, right? So if you can read it carefully, each and every aspect, comma and percent and all these things, these parentheses and all those arrangements, and if you read the output, so we have derived this output after a simple parsing mechanism. So if you can read here, right? So we have, first of all, we have make it a lowercase thing. So earlier it was uppercase, then it is made as a lowercase. Then you can observe here, this part is also removed. This part, right? This is now having this presence. You can carefully observe. Then we have this as a token, this as a token. We have now removed it. This part is okay, it is there. So this biannual is removed because it is not making a sense and it is basically truncated. This these two, this by term and these two things has been removed. Then we have annual as a token, report as a token, showed as a token, profits are kept as it is, right? Rows is kept as it is. This 21 and this percentage and this dot. So primarily, if so this for a simple sentence, we have applied parsing and we have derived these set of keywords, right? Naturally, it has lost a lot of meanings. Semantics has been lost, but it has been derived in a form of tokens, right? And so this is the very simplest form of example where you can analyze or we can note down that, okay, for a basic parsing mechanism, we can have this kind of input and these kind of output, and here you can carefully take out each term as a token. Each term is equivalent to one token, right? So we cannot say that this is a sentence, maybe not so grammatically correct or accurate, but Parcel will give you the tokens, right? Text tokens. So you can see here we have kept profits as a token, though profits is not the original term. We have added this s to make as a plural, right? Similarly, we have added here showed, showed, which is not the original word, English word or English term, right? But the purpose of Parcel is to derive the possible tokens, to remove all these things which are creating a lot of problems. They are not independently having any specific meaning, at least for the search behavior, right? So that's what the reason we are placing these components, parse and all these things, to make it into the searchable template or searchable format, right? So typically, if you can relate, so the basic purpose of it to derive the tokens. So whatever input we are providing, it will be performing some pre-processing, some basically denoising to perform tokenization. So the outcome will be, whatever outcome we will be getting, it will be in the form of tokens. So suppose in this simple text we have placed the URL or maybe website address like www.microsoft.com. It will remove www part and it will remove a dot part. So it will keep this Microsoft.com part as a 3 different tokens, right? So it depends. So most of the cases, this parser components largely depends upon the compiler you have adapted, the compiler you have designed for your purpose, right? So in the most of the search systems, most of the information systems, the parsing component is customized. It is designed as per the application need, right? So if you adapt the standard version of Parcel for your application, it will perform a very low level or very traditional or minimal level of tokenization. So you should, whenever you are designing a search system, whenever you are designing a pre-processing component, you should always customize the parser based on your requirement, right? Because parsing is something which will remove a lot of these noises from your text, right? So after getting these kind of notations, after getting these kind of tokens, you can send these tokens to the very next block, which is called stopping, right? So here is the basic, before going to stopping component, you can see here, this is again a diagram taken from one of the standard book, and it is demonstrated the basic idea that how a particular lexical analysis, because we have placed lexical analyzer in between these two phases of parsing. So if you go inside this lexical analyzer block, you can easily read out. So these identifiers, letters, digits, these are placed into a symbol table. right? So similarly, if you want to customize a parser, particularly a lexical analyzer, you need to broadly work upon the symbol table. So for your own application, you can add lot of symbols, lot of things into the symbol table, because this entire working of parser, entire working of lexical analyzer is based on the symbol table. Dictionary naturally is always a standard thing, is a standard input for a lexical analyzer, but symbol table is something you can always customize. In most of the cases, it is the symbol table which makes this whole parsing thing as a customized or personalized, because we used to add a lot of symbols, lot of identifiers into the symbol table, right? So whenever you want to prepare or customize a parser, you need to customize this symbol table, because naturally dictionary you can customize, but it is a difficult task to perform it, of customize dictionary, right? Naturally, most of the researchers are working upon this part, that how to derive a dictionary. There is the one amazing fact here, that Google search engine, from the last 3-4 years, they are working on a project in which they are actually deriving or generating a dictionary based on the user search on a different languages, right? Maybe in the future, maybe after 8 or 10 years, whatever you are typing in the Google search will not be corrected based on the dictionary, maybe based on the grammatical syntax of a particular language. It may be based on their own dictionary. So nowadays they are having this translator. Google is having translator for one language text to one other language text. So nowadays it is purely based on the grammatical structure, a dictionary of two different languages, source and destination language. But in the future, they are having a large scale project, and on that they are gathering the grammatical structure, how users are typing and how users are behaving on the search system on the different platforms, and based on that they will be having a altogether new grammatical structure, altogether new dictionary, right? They will be not basically based on the standard grammatical structure and standard dictionary of any specific language. So that is how they are preparing, so based on these two derived things, their parser and their pre-processing component will be working. So it is the text transformation part which can be basically modified, which can be customized to achieve or to build certain application, right? So like if here you can see we have placed this symbol table. Similarly, you can add your own identifiers into it and achieve a certain parsing tokenization process, right? So after this, if you look into the second block, which is stopping. Now stopping is basically again text. So stopping is something you can say it is a denoising phase, because in the case of parsing we have removed some symbols kind of things, some identifier kind of things which are not having any impact on the structure and the meaning of the content. But in the case of stopping, we are actually removing the words, right? So that's why it is referred as the words, removal of words or removal of stop words. So we are having some, so for each language expression, for each kind of text content, we are having, or we could have a stop word, right? So which needs to be removed from the streams which we have is achieved from the parser. So parser component have given you the tokens, right? You can see here tokens, and from this token stream, from this list of tokens, you can easily remove these some set of words which are called or which are assumed as a stop words, right? So typical type of stop words are basically A and the, that, those. So these kind of stop words you can easily identify, right? Similarly, so in most of the scientific documents, there are name of authors, the name of some instructions like click here, move over, and see under, below, all those. So you can easily identify these stop words, right? So stopping component is one of the component which is often modified, right? So whenever you are working on the design of algorithm for text processing, or maybe suppose you are planning to design a system where pre-processing is required, pre-processing on text is required, stopping is the very first block which is very often customized. And to customize stopping block, you need to do two things. First, you need to identify the extremely common terms, right? Extremely common terms or common words from the document corpus or maybe text corpus you have collected or you have received from Parcel, and the terms which are having very little meaning or little impact on the meaning of the content. So for this, you need to apply some kind of statistics. You can use that. Okay, these are the terms which are commonly occurring, so it is frequency is high, and these are terms which are not having any manual meaning. So because I'm saying that naturally there could be some standard list of words, like we are saying in a text documents, these terms like the, a, and that, those, these are the very established terms for stop words, or established terms which can be assumed as a stop word. Along with it, if you want to add your own list of terms into this stop word list, you can do that, right? So this is a very mechanical task, and it is always to be performed, always to be provided to the system, right? So whenever we are building a text transformation block, it is important, particularly in the case of stopping phase, you need to provide some set of stop words from your side also, right? So whenever you download a library from the internet, any natural language processing library for stopping, to perform stopping pre-processing, you need to add some keywords. Naturally, in each library of stopping mechanism, they will be having some set of stop words. On that, you can always add your own preference, your own list of keywords, right? So to perform this, you can start by assuming that which are the words which are appearing extremely high occurrence, or keywords which are having very little meaning. So these are the two primary or basic criteria to identify the stop words from your document collection or from the text collection. And other than also, you can have other criteria that based on this criteria, what are the keywords, what are the words which are having this presence. So let me add these keywords, these terms into the stop word list and use it to remove these keywords from my text documents, right? So naturally, you can have your stop word list, and based on this stop word list, you can perform stopping, right? So naturally, that should be in the balanced manner. So you cannot have this stop word list in the extreme way of doing it. So because removing this stop word, so you need to take out these three after effects of stop word removal very carefully. That whenever we are removing, so we have prepared a list of stop words, and when we submit this content or token streams from Parcel component to stop word or stop algorithm, these contents, these keywords which we have provided as a stop word will be removed from these token, right? Token stream. So this is the typical way of doing. But if you have prepared a stop word list of huge stop word list, suppose you have prepared, and if you remove these stop words from your token stream, so naturally the one advantage is that you will have lesser size of possible terms, lesser index size you will be having, right? So all those terms which has been removed will naturally not be the part of index database. So that is the one advantage which we will have. Along with it, naturally it will remove the retrieval efficiency, because index size is less, so retrieval will be efficient. That is very obvious thing. So but generally, if you go for the extreme level of stop word preparation, and in suppose if your stop word is huge, so maximum terms has been removed from token streams, so index size is less, but retrieval is efficient. But generally, it will have in this positive side of effect for the very trained users. So if your user is not trained, if user is not familiar about the keywords, so it will have some negative effect also, but it is rarely observed. So generally you can say this whole stopping or stop word preparation will have positive effect, right? So you can have this perception that whenever we are preparing a stop word list to perform a stopping mechanism, it will have the positive effect, because eventually we will be keeping only potential important terms in the text, right? All the repeating, all the so common, so obvious terms has been removed from the text, and naturally these terms will not be posting during the search process. So it is basically optimization task, right? So identifying stop words, possible stop word, is optimization task, and many other researchers are also working on this part. So whenever they are performing some text processing in their application, they are having a separate optimization algorithm to prepare the stop word list, because it will have always this positive impact on the performance, right? So we have not placed any specific example here, or maybe this is a very generic example for given input, like this is your input text. For this input, you can prepare the text stop tokens, and after getting the stop words, naturally tokens will be passed to stopping block, stop word removal block, and based on the stop word list, you could have these possible terms. I'm not saying this is the accurate conversion for after applying the stop word removal, but you can have this kind of thing. So after submitting this set of input to the parcel block, right? Parcel block, it will give you the set of tokens, right? Set of tokens, and set of tokens will be sent to the this stop words. Then based on the stop word list, it will rectify, or it will remove these stop words from the tokens, and naturally you can have, possibly you can have these kind of basically terms, right? And naturally, if you further want to perform the last level of processing, which is stemming, because you can see here we have not placed the original word. So you can have, we have placed words which is not a original word, right? We have placed learning, which is not the original word. So machine is original word, apple is original word, so this term is always not a original word. Text is original, paragraph is original. So the last part which is left here is to, because keeping these terms like words, learnings is considered as a basically a problem for the search system. So in the last, as a last part, the last step, we will be performing some processing to basically identify or to establish this root word, right? Root words. We cannot have these kind of words, right? So for that, the last level of processing is done, which is called stemming, right? So stemming is the objective that you need to reach up to the keyword, root word, actually root meaning, or the first word. So for words, word is the root word. For learning, learn is the root word, right? So because it is the derived word, it is not the root word. So stem means you will be performing the root level of word, or root level of text, right? Else all the things have been removed or rectified or denoised, right? So tomorrow in the next lecture, we will be discussing upon the two important algorithms for stemming. Two important means there are two fundamental algorithms has been placed in the domain of the stemming. So if you explore to the research papers of stemming, you will be having these two algorithms. First is called Potter's. So between these two, Potter's algorithm is widely accepted and it is widely adapted for their work. So naturally, if you look into the literature, you will be having a lot of modified versions of Porter algorithms. Nowadays we are having 10 to 20, 10, 18 or 20 versions of Porter's algorithms for stemming, right? So there is other algorithm also which is very less explored or less adapted by the different application domains. So in the next lecture we will understand that how these two algorithms are having their internal working and why one is better than other, why Porter's algorithm is widely accepted, and how you can adapt this Porter's algorithms for your own work, right? Because most of the stemming algorithms, most of the stemming solutions are coming from these two algorithms only. Mostly they are influenced by these two algorithms. So naturally, in the next lecture, we will be discussing these two algorithms, their notions, and we will be taking upon some related questions from this text transformation block. Right? Okay, so with this, I can close the lecture. Okay, now we have got some questions. Okay, how does Parcel works in XML type documents as they have user-defined text? Well, okay, so naturally, whenever we are, Akanksha, whenever we are preparing a parser for web content, right? You need to add these notions, these XML structure notions, XML structured contents into the identifier. You cannot have a parser, default parser for parsing the web content. Web content means XML pages or HTML pages, any kind of things, right? So you need to redefine, you need to add these symbols into the symbol table or identifier as identifier, right? So it is always necessary to modify the symbol table if you are dealing with the web content, if you are dealing with the any kind of metadata. Again, we have question. Okay, so how to work with encrypted documents in which spaces and special characters are intentionally added to maintain hash value? How to parse them? Type of documents. So again, I'm saying this parser component is having this capability to remove or to define. Like in the traditional way, hashtag thing, hash value is to removed, right? But if you design parser by keeping these intentions that I should be removing, I should be counting these things, counting these notations or structures or maybe terms, you can have these things into the symbol table, right? So for encrypted documents, naturally you have to again there is a term called normalization. So before starting the parsing process, we have not discussed that term because we are getting nowadays, we have observed that most of the documents are encrypted. So for that, there is a pre-processing. Before parsing, we have this term called normalization. So you can have a brief idea about the normalizer. Maybe in the next lecture, we can take out some hint about it. So you can go to the internet and search what is the purpose objective of normalizer for encrypted documents. Okay, there is question how we define which word is original word. Okay, stemming is basically based on the dictionary, purely dictionary. So if you could, Kanaya, if you could explore go to the internet and search for Webster dictionary. So there is a dictionary called Webster. There is a lot of dictionaries also available. So naturally, this stemming is always performed with maybe based on some dictionary or maybe based on some there is a term called ontology. So ontology is also sometimes used or maybe semantic web content. Semantic web is also used to identify the original word. I'm not saying these whatever terms defined in the dictionary are the original. You can derive your own ontology structure, your own web semantic structure to perform semantics, right? Okay, so Vishwas says can uppercase to lowercase transformation can give us proper result in all cases if some of the words have uppercase, lowercase have different meaning. Yes, so it always depends on the basically typing approach, but a such system assume that uppercase, lowercase are not a significant thing. That's why most of the search system are having this impression that let's normalize it, let's remove this uppercase, lowercase notion and consider both ways. So if you experience this, you just go to the Google search and perform this experiment, that how this uppercase lowercase is having any impact or not, right? So if it is having impact, naturally they have some kind of mechanism to consider that uppercase is having a certain importance, and to retrieve the results for uppercase term and lowercase term, they need to have some mechanism. So similarly, you can have this impact, right? So it again depends upon your notion. If you want to make uppercase lowercase with some importance mechanism, some importance to it, then you can achieve this by modifying the Parsing and Lexical analyzer. You can have capital A and small a both identifier into the symbol table. If you want both notions, both small a and capital A, as a similar, you do not need to bother about it, right? You need to simply normalize it in the small a. So whenever it is having this appearance of capital A, it should be simply converted or transformed into small a, right? So whenever in the future user type small a or capital A, it will consider as a small a, something like that. So with this, I hope questions has been answered. Naturally, in the next class,